Sorry.
G'day guys, welcome to the, what are we, August? September. Welcome to the September.NET user group. Thank you for coming. We have a big night on tonight. We have a dual session by Nelly and Stafford. But before we do that, we might just talk about news. Have we got any cool news that have happened in the last month in the tech space? Simon, got anything cool?
Just today we announced the new serverless framework support for Azure Functions.
Okay, so Simon Waite says what is it?
The serverless framework support for Azure Functions.
Serverless framework for Azure Functions. Okay, just do a quick search on that. Okay. All right, cool. And is there any other news?
Other news, but it's all about Azure.
It's all about Azure, all right. Cool. Have we got any other news? We'll come to Azure in a second. Okay, so .NET Core release candidate 1 was released. So .NET Core Core 3 release candidate 1, and we are actually already building on it. So it is very solid. We have no problems, and it has some cool stuff in it, such as Blazor. Okay, so is anyone using Blazor? So Blazor is a new framework. It's a new web framework.
It's OR.
Blazor OR. And probably that is going to get you, without the word .NET, that is probably, oh, wow. Wow. It's impressive. All right. So, yes, nice, cool logo. Is anyone seriously considering building on Blazor in the next 6 months? No one. Okay. Yeah, we're a little frightened ourselves, and we're waiting to see some clients ask us, and they talk about it, but no one's commissioned a project on it yet. So yeah, we'll see. And there's Entity Framework is news as well. So Entity Framework 6.3 and Entity Framework 3. So Entity Framework Core 3 and 6.3. Yeah, 3 and 6.3. But so that's the news there, and that is exciting news as well. And I'll just give you a couple more pieces. Visual Studio now has that terminal, the integrated terminal. Does anyone care for an integrated terminal? Yeah, it's good. You don't want to switch out to your terminal. You want it inside Visual Studio. There we go. So that is the cool news there. And obviously you could switch that to Bash if you wanted to, whatever. It's just that article. Click that article. Hopefully that might even show you how to configure it so you can use other settings. But yeah, anyway, so that's cool. And I guess I should also, I will mention one other stupid thing. Can you just search YouTube space Adam Kogan 2000? Yeah, okay. Enter. Let's see how we go. This year, this week, can you believe this? I had the worst. Sorry, I'll just take that off. You won't believe what happened to me this week. I thought I might tell you. We had a new renovation done downstairs on one of the suites. And, it's not there. Oh yeah, check this out. This is ridiculous. This is absolutely ridiculous.
Holy moly. So this is a huge crash. The floor shook, windows broken. First time I'm going in here, I'm not even frightened of going. Oh shit. How am I going to get in? Oh, I seriously can't get in. That's bad. So this cupboard that only had some folders in it and the other cupboards were empty has come off the bloody wall. I don't know how well secured this is. Smashed the 4 monitors, smashed the 2 computers, smashed the 2 tables. I don't know if they've smashed the chairs, and this is ruined. All the decals that we've just had put on, ruined. Get a load of this. This is a strong wall. You know, it's a structural concrete wall, and these builders have gone ahead. Like, somebody could have died there. 2 people were there just a few hours ago. And put the cupboards up here. These are like, this room is unsafe now. Those cupboards could come off. I won't even explain how dumb this is. They put stand-up desks here that can't stand up, but that's a whole nother story. And this, you know, I wouldn't want to put, God, strike me pink. God, that's probably too much weight for this stupid thing. This stuff is not on structural walls. This is not on structural walls. This is just partition walls. Partition walls. Completely ridiculous.
Anyway, we got a very fancy company. Oh, yeah, it's not touch. I forgot. It's a Mac. We got a very fancy company to do that, which really royally pissed me off. But I found out something. I don't know if there's well, the fancy company employed another company to build the cupboards, and that cupboard employed another company to do the installation, and that company got some Brazilian backpackers to screw it on the wall. And you can see these different levels of abstraction causes a problem in the end. And yes, very, very nasty. Anyway, that's my news. Now, bigger news, happier news. Got some news for us, Nelly?
Which one?
MVP?
No. It's my birthday as well. I
Oh,
think
birthday.
About us.
Oh, all right. I think that's
Too many years.
Yes. And how old are you?
I can't tell that.
I know, but congratulations. You deserve to be an MVP. That's a big feather in your cap. So that's awesome. So with that, great news. We're going to hand over to Stafford and yourself. And I'll let you guys kick off.
I think that's mine.
So, welcome everyone, and thanks for joining us. My name is Nelly Sattari. I'm a lead developer from Challenger and very fresh Azure MVP.
And I am Stafford Williams, lead consultant at Telstra Purple, previously known as Readify.
So, we are going to talk about thousands of concurrent connections with Azure SignalR Service, which is a new service. So what we are going to cover today is just real-time applications in general, a little bit about the scaling and the problems and the solutions, some serverless approaches, which is cool, and a very cool audience interactive demo, which you wouldn't like to miss. Okay, let me talk about one of my experiences before actually we start to make sure that we are all on the same page about real-time applications. So I work at 5 Martin Place in Sydney CBD, and we have a very luxury reception. So in the reception, we actually every week buy a big flower bouquet, which is really beautiful and expensive. So at the end of the week, we are not going to throw it out. So we just we just put in a bid for the flower bouquet, and everyone across the company can jump and place the bid. The problem is whenever I participate, I actually win the competition. So everyone think I'm either so lucky, which I don't deny, or I'm probably I put like much higher bid than the other people, which is not really true because I just normally win with a few cents differences. The thing is, the first time I just jumped into the website, I realized that there is no real-time functionality in the website. So I took a very high technical solution, which is this.
But we're developers in here, so we'll make it a little bit more high-tech and use this one.
Yeah, I could use this one potentially.
Hands up if anybody knows what the true means. It means reload that. Don't reload that from the cache, pull it from the server. And the reason for that is because traditionally, or by default, the web is request response. We've got a client or a browser that's going to call a web server, ask for that page that we want to see, and then that web server is going to respond. It's going to cut that connection. What we're doing in those previous slides is just reproducing that somewhat inelegantly. When we talk about real-time applications, what we are talking about is those that push that data once it's available, rather than having to use those methods that we've just seen.
So although it's really interesting to use real-time functionality for many applications, it's actually essential to use for some others. The examples are social media apps. So you know that how it's pleasant to get the notification just in time. Or another example is online dating. So nobody will date with someone who is not responsive. So you need to get the messages to respond properly. Another example is any kind of tracking applications, including Uber tracking, tracking your shipping package, or maybe sometimes your kids in the school car. Other examples are like online gamings, where people jump to play together, and then if you just lose 1 second, you will lose the game. Any kind of dashboards, including security dashboard, incident dashboard, or flight dashboard, when some events happen and you want to get the new content or notifications. In general, real-time applications probably is the best candidate for the website with high frequency update and the ones which are based on the event-driven architecture. So we talked about some generic examples, which you might not really care about it, but we actually want to do a kind of experimental test today and see what in this room right now, what kind of things we can improve with the real-time functionality. So I would like you, please, to just scan this QR code for me.
So if you're on a iOS device, I believe you can just switch up that camera and face it at that thing. I'll make it a little bit bigger for you now as well, like that. And you should be able to connect. I'm going to try and connect from here as well. Cool. Look, I can. A little icon will pop up the top, and you should be able to join our session. We've got at least one player connected there. Am I connected? I don't think I am. Oh, it asks you for your name. I've entered my name. We've got some people in there. I'm going to skip back to the slideshow.
Cool.
And go on, do it. And we'll just close that out for now. Now,
okay.
If you look on your screen, you should have this slide.
So you got my slides on your mobile, right? So what is the best? You don't want to take the screenshots from the monitor. You have everything on your mobile. Let's talk about the rest.
So let's have a talk about how traditionally we have implemented real-time applications. Long polling is a approach that we had mainly between the 2000-2010. And we were using that where we'd make an HTTP request, we'd hold the connection open. Once the server had some data, we'd respond. and we'd close the connection. If the server didn't have any data, it would just keep that connection open. The moment that the data came through and we closed it, again, the connection would just immediately open and we'd wait until the next piece of data is there. Key point to note here is that every time we're repeating these requests, we're sending full HTTP headers. So we're just going to repeat that over and over again. Come 2010 onwards, certainly with HTML5, there were some better approaches than that. One of those was server-sent events. Server-sent events is one-way communication, persistent connection from the server to the client, in that we don't drop that connection, we hold it open, and when we have messages to send from the server to the client, we just send them. We can do that without sending headers, which is nice in the name of efficiency. It gives us low latency. Unfortunately, it is not supported by Edge or IE. Until that new Edge with Chrome comes out. I don't know if that's shipped yet. Has that shipped yet? In development. So I think it's Chrome, I want to say Edge 87 or something like that. Anyway, there's another, or just a quick overview of what that looks like. On the diagram, we've got that first or initial HTTP request and response coming through. We're going to open that persistence connection, which we're not going to drop. We'll keep it open for the lifetime of the session. And as new events become available on the server, we'll just push them through to the client. It doesn't go back the other way though. WebSocket is another HTML5 feature. And the difference is that it is bi-directional. So if we look at our diagram here again, we can see in that bottom little loop one, we've got data coming from the client as well. So that persistent connection is going to be made on that first request response. We're going to keep it open, and whenever the client or the server has messages to send, they'll just send it across that connection without the need to send new headers, etc.
So which one do you recommend? Which one are you going to use?
Well, I kind of like WebSocket because it lets me go both ways, but obviously the requirement there is that the client and server combo both support that. So yeah, I'm not certain.
Okay, let's go with another solution. So ASP.NET SignalR. SignalR is one of the most popular open source libraries, which was shipped with ASP.NET years ago. And that actually provided kind of real-time functionality for the applications. So the key benefit is SignalR out of the box knows how to pick the best method based on the client capability and servers. So if WebSocket is available, it will go with it. Otherwise, it will gracefully fall back to the other methods, which we already discussed. It is originated in 2011 by David Fowler and Damian Edwards. And the good thing is it provides the server-side and client-side library for us. After a couple of years, it actually came with ASP.NET Core as well. But it's a complete rewrite. So if you have some legacy applications which works with ASP.NET SignalR, it's not like straightforward to move it to ASP.NET Core. You need to fix a few things. Let's have a flashback to my bidding Flower application. So I acknowledge that it's not a really fair way to just press the F5 and get the latest content, because not everyone knows that the website doesn't have the real-time functionality. And people need to have transparency and enough, equal data. So I came up with a solution, which is ASP.NET Core SignalR for the backend and the Vue.js for the client side. I would like to show you the quick demo, like a POC that I provided to. That I provided for the company to show them how easily we can actually add the real-time functionality to our applications. I refresh my application. This is my mobile. So I connect to the site. This is the client site hosted in Azure Storage. And can I get you, please, to connect as well? Or are you already connected? OK. So you can see whoever connects to the website, immediately everyone get notified that who joined. And then once I put some bit here, you can immediately see on your device. And if you do it, just now you enter, OK. And without any delay, everyone can see what is the latest bit. So basically, with no delay, everyone are in the same page, so it's fair and transparent. Let's see how actually I built this application. So you still have everything on your mobile, so you can have a look at the code. Basically, in your ASP.NET Core, you just inject the SignalR service with one line, single line. Then you provide a route for the client, so my Vue.js application knows that it should connect to this route. After that, it will fall into this hub class. So all the methods in the hub class are publicly available for the clients. So a client can make a call to any of them, send a message, and then the server will broadcast the message to all other clients. You can see that I use the clients. I can use a group of clients, or maybe just one single client. Then I hold the application in Azure App Service and get the URL back. Then my client side can easily connect.
So for the client, we need to install the SignalR JavaScript client, which we can now do via NPM. If you remember SignalR before ASP.NET Core, it was shipped with NuGet. Now it's on NPM, which is much nicer. If we type that code, we'll install it, and then we can configure it pretty easily. This is looking at our application setting up a hub connection. We can see in there the URL that Nelly just showed us that she deployed in that previous slide. And then down here we can send messages from the client to the server using that hub connection that we have configured. Coming back the other way is pretty simple as well. On that hub connection that we've created, we can register a callback for the server to make RPC calls to us, and then when we've got them, we can do whatever we like. For example, show a little alert box.
Yep. So SignalR works fine as expected, until actually we push it under lots of traffic. So when you hammer your website with lots of clients, you would have some problems. Let's look at the problem. So some people believe that SignalR can handle unlimited persistent connections. The truth is it cannot really. And the reason is every server has limited resources in terms of memory and CPU. So at some stage, the server will reach the limit and the maximum capacity. The thing is the persistent connections consume lots of resources in your server, more than normal applications. And the reason is, if you look at this diagram, in the typical web application, when the client make a request to the server, it will get back the response and will go away. The second one get the response and go away. The third one. So you always have some room for other clients to connect. The fact is, with real-time applications, while you have the persistent connections, all the clients are just sticking to the server, and they are not going away till actually they close the session. So you can see that the server getting overloaded and getting, reaching the maximum capacity so quickly, much quicker than normal applications.
So in that diagram, we saw 3 connections overloading that server. Probably, realistically, it's going to take a little bit more than 3. I wanted to discover how many it would take. So to do that, I used a load testing tool that comes with SignalR.NET Core already, called Crankier. It's part of the ASP.NET SignalR source. And what it does is you can configure it to point at a server of your choice, and then it will just raise multiple threads, multiple connections, as many as it can, or that you configure to that server. So I took that and I stuck it on my local machine, and I pointed it at an S1 app service. If anyone's familiar with the limits on an S1 app service, the official Azure page says that it has support for unlimited connections. I got 768, which was much less than unlimited. Upon getting in touch with Azure support, I found out that that was a per client a restriction or limitation. So I needed to run Crankier on more than just my local. So to do that, I chose containers. I stuck Crankier inside a container. I raised 50 of those containers and I pointed them at my S1 App Service. In doing that, I was able to get 16,000 connections, concurrent connections, which was much more than 768, but probably not enough for me. Because that per client restriction is still in there, that's what's limiting that 16,000 number. So I switched out the S1 App Service for a VM. I put the Crankier server on that VM, I pointed those 50 containers at it, and I was able to get about 65,000 connections. That's a big number, but still not high enough for me. And the reason that's not high enough is I looked at the resources, memory, CPU on that D2S VM, and it still had more. So on inspection, the containers, when you bring them up, a number of them for unknown reasons, max out at about 500 connections in total. Only for that 65,000, only let's say 2 or 3, 4 of those containers were making up the rest of those concurrent connections. So I needed to resolve that issue, and I did so with VMs instead. So automating VMs is it's not as simple as automating containers. We can raise containers with one line of code. Raising VMs, installing Docker on them, and orchestrating them is not super simple. I've got a whole lot of open source software that I've written to do this, which you can check out at the end of this presentation. But pointing those 50 VMs at that tiny little D2S VM did manage to use 100% of its resources. And I got about 100,000 concurrent connections off that. So now that I've saturated that server's capacity with all of those connections, it's time to start ramping the server. So that number is wrong. There should be a D8S. With the D8S, I got about 214,000 connections. So that was a server 4 times the size. I got about 2 times the amount of concurrent connections off that. On the last test that I did, I raised a 32 core VM. I found out that by default Azure doesn't let you raise more than 20 cores per region, so I was raising 20 cores in this region, 20 cores in that region. So I've got 100 cores across those VMs, another 32 cores across those. How many regions is that? 5, 6, something like that. But I was able to get about 245,000 concurrent connections. That's the most I was able to get, and the resources on that server were only at about 20 to 40% as well. So that's an implementation restriction that we're seeing in SignalR there.
All right, I'll disconnect you from the slides if you don't mind. All right. So let's see how we manage this pressure when the website is under the high traffic. So we just discussed that the server is getting loaded by a persistent connection, and as a rule of thumb, what we do is just scaling the servers, and it's fine, we do it. However, with collaborative clients, when they want to broadcast messages to other clients, it's not that easy really. Let's say the first client broadcasts a message to the server, and the server is expected to broadcast messages, which is fine. All these clients get the message, but what about the other clients in the other servers? They never get the message because the app server 1 doesn't have any idea about the other servers. So this is the problem with collaborative clients. We have basically 2 solutions, which I asked Stafford to talk about. The first one, which is the traditional solution.
So the backplane is a setup where we install something that's going to sit behind our servers, that's going to manage all these connections that are coming in for us, and manage the messages coming in, then send them to the right clients, then also manage our broadcasting such that we send those to the right clients as well. So it's going to propagate that connection information for us. And this is what it looks like. I think there is a diagram here, and there is, sorry, an animation. And that message from, let's say, one of those clients is going to come in. It's going to hit the app server that's associated with it. It will go to the backplane. And then in our broadcasting scenario, we'll use that to send out to those app servers and out again to the clients. Now, the installation and configuration of this is not super simple. Additionally, we will need to deal with sticky sessions. A restriction of the newest version of SignalR ASP on ASP.NET Core is that any message that or any connection that a client has made to an app server, we need to maintain that connection for any messages that we send to or receive from. So the backplane is going to have to sort that out as well. Got something better for us, Nelly?
Yes, I do. So if you're looking for a better managed service, maybe this is something that you want to have a look. The Azure SignalR Service. So it's a modern solution. It's pretty new product, came out last year. And the way it works, it's actually a proxy other than a backplane. So it means that the persistent connections are not taken by servers anymore. They are delegated to the Azure SignalR. So server is no longer taking any persistent connection. And that basically solves our problem because the client and server doesn't really stick to each other and server is not getting loaded. If you want to see it on diagram, so the client make a request to the server and server, instead of sticking to each other, server actually send back the URL of Azure SignalR Service, which is good because the client now can go and connect to the Azure SignalR Service instead of server. They actually both connect to the service. So it kind of sits in between and works as a proxy. So the data channel established between from client to the server through the SignalR service. So if a client sends a message, it will go to SignalR service first, and then SignalR service knows about all the servers and the clients. So it will broadcast messages to servers. And then it's easy because servers are aware of all the connected clients. The problem is solved. So this is my bidding application again. I just bring the network tab a little bit bigger. So you can see in the first request, the client actually make a connection to server, which is the first URL. But what we get back is another URL, which is the URL of Azure SignalR Service. So you can see how client is redirected to another URL. The setup is easy, really simple. So you just looked at our bidding application without a SignalR service. Now I just show you how we inject the SignalR service as well. So this is the original code you just saw. And we replace this line with add SignalR with Azure SignalR. So we make sure that we actually have introduced Azure SignalR as well. And the URL you can see is the connection string for the service. And I show you how to get it later on. And also the second line, you used to use SignalR, now you use Azure SignalR. That's the only change we need to take. So how we create the Azure SignalR to get the connection string is just through one simple line. So you can use Azure CLI, which I already use, or you can use any ARM template and then spin up your service in a few seconds. Then you can go to the Azure portal, which you can see here, find your SignalR service, and then look at all the logs or details, everything about the service. And then you can get the connection string from the key section. You can see another section in the SignalR service, which is the scale. Well, what is the scale? So SignalR basically scaled by units. So if you have like more than what it can take, it will scale by units. It means that each unit can take 1,000 connections. And you cannot really go more than 100 units. It means in total, you would get 100,000 connections. That's the thing.
A question that Nelly and I often get about that is, can we auto-scale that? if you see on that previous slide that we just came from, you can jump into the portal and you can set the unit count to what you wish. But can we do that based on load? By default, no, we cannot. However, we can use Azure functionality to enable this for us. And here's two great examples of doing that, either a Logic Apps approach or an Azure Functions approach. Having done one and seen the other, I would probably prefer Azure Functions for this specific task. But basically, they're both going to do pretty much the same thing. They're going to call the REST API, Azure's REST API, and they're going to be calling three endpoints. This first one is metrics endpoint that lets us, or that tells us how many concurrent connections do we have right now on our service. We'll take that and we'll combine it with SignalR get, which tells us how many units have we currently got configured on our service. And then if we do a little calculation and determine that we're going to need more units or less units than we currently have now, then we can call this one, which will go and update that SignalR service for us to that unit count that we want. An interesting note is that valid unit counts are only those. You can't say, for example, set a unit count of 3 or anything that's not that. That's the implementation currently. Additionally, pricing is interesting with that due to the fact that right now it's not really consumption-based, considering if you set a unit count of 50 right now for that 24-hour period, you pay that price per unit per day immediately. Which means that scaling back down during any 24-hour period is not too beneficial for you. With that in mind, there's messaging cost as well. So we're going to need to ensure that our applications are a little bit less chatty than otherwise we might have done. However, we need to weigh this up against the time that it takes to configure a back plan, the complexity involved with that. Additionally, when we're thinking about how many units that we need to determine what kind of problem we're solving. Are we keen on broadcasting to a lot of clients? Are we keen on a lot of clients talking to us and that kind of thing? There's good documentation on docs.microsoft right now that explain some of the caveats based on what solution you're providing, and so it's a good idea to go and look to see if you need those unit counts. For example, some solutions switching that unit count from 50 to 100 is going to have no noticeable effect.
All right, it's time to go serverless. So Azure SignalR resolved lots of critical issues around the scaling, as we just saw. However, we still have a few other issues. One of the issues is this, SignalR is a great library, as you could see, but it's tightly coupled into ASP.NET and ASP.NET Core. So the thing is, if you're not a .NET developer, what would be the solution? Should you be excluded or what? The other problem is, as you could see my code, it's quite monolithic design. So I have like a connection management, like hub class, sending messages, receiving messages from clients, everything in just one big application. And in reality, if I have probably some database connections and integration, I would have them in the same solution. So that's a bit of problem. So breaking the serverless actually bring this opportunity for us to move and break down this monolithic code into microservices design and moving toward the event-driven APIs. And if I'm not a .NET developer, that wouldn't be a problem because I can use Azure Functions with any language that I really like to do, like JavaScript, Python, or whatever. If you want to switch to serverless, it's really simple. So you just pop into your Azure dashboard and you find your SignalR service that we already created, and you switch the mode between serverless and classic. That easy. It's all you need to do in Azure side. Then you need to provide some Azure functions because we are not going with ASP.NET Core anymore. One function is required, which is the negotiate function. So basically what it does is client make a call to this negotiate function, and then we'll get back the URL of Azure SignalR. Then client can connect to that Azure SignalR. That's it. The second, or probably you might have more of these functions, but any kind of broadcast functions. So due to any event in your environment, you have some content or message to broadcast to all clients. So you just provide a broadcast function, and then it has the message, and it knows how to send it to the Azure SignalR and then broadcast it to all clients. And this is the diagram. You can see how it happens. The fact is, I just want you to make sure that you get this concept of Azure functions are not dedicated VMs, right? They're not running all the time. So they execute your code, and they're going away. So there is no basically dedicated server that clients can connect to them persistently. And the servers cannot basically connect to the Azure SignalR as well, because they're executing the code and then going away. That makes us thinking of the client as listen-only mode, which is fair enough. You get some benefits, but this is the restriction you have. So since there is no dedicated server, they cannot really send back the messages. And my message is just to make sure that you choose your serverless solution carefully for the scenarios that the clients are not really chatty or collaborative, because they cannot really send a message. One of the examples I just thought and provided a demo for you is just this flight center application. So basically all over the world, whenever a flight is landed, all the connected clients can get the content immediately. So as long as you're staying connected, you can see all the flights. And as you can see, it's just one-way communication, which works well with a serverless solution. How they work, how Azure SignalR and Azure Functions work with each other, it's actually a very productive programming model in Azure, which I really like it. It's based on triggers and bindings. So triggers are what makes a function to be executed, and the binding is the way that one function talks to other functions. It can, so one function can get the messages or data from another functions or pass the data to them. So let's say in our example, in the flight center, any third-party flight API basically populate the message or the content in our queue in Azure. So the queue can be basically a trigger to the function. So queue trigger the broadcast function and pass the content to the function. And the function has a binding, SignalR binding already set up. So it passed the content to the SignalR binding, and the SignalR binding out of the box knows how to broadcast messages and content to the clients. The way you basically configure it, it's really simple. This is my function, broadcast flight function. And you can see you can go and set up your trigger and your output binding. So you can do it in Portal, or you can do it through JSON code or any kind of configuration code. That's what you need to do. And the code that you need for your broadcast function is just these few lines. So queue make a call to this broadcast function, pass this queue flight, and the content is basically sits in this parameter. You change a little bit of this parameter, make it like suitable for SignalR, because SignalR needs the actual content as well as the client-side event, which is listening to the server. So you just introduce what client-side event is listening and what is the flight, and then connect it and just attach it to the SignalR binding. That's the whole thing you need to do, nothing more. So this is all the contents we wanted to cover. Let's get back. I think it's Wednesday night, so you deserve some nice games, probably, real-time games. You still have your mobiles connected to this website, right? The logo that you just, the QR code that you scanned.
So
I'll let you run the game.
we're just gonna, there's that mobile if anyone else wants to connect to it. It will stay on the side whilst we're having a look at these experiences as well. The first one that I'm gonna start with is broadcast. And if you've noticed on your device, you should see a little bell, and you've definitely noticed because you're hitting that bell like nobody's business. Some people like to think that we are faking this, but if I ask everyone to stop hitting the bell, it should stop, and it does. Yay, now smash it again. Yes, it should speed up again. Great. That's interesting. This is sometimes a little bit more interesting because if you look at your device, now what I'm typing is appearing on your device, I hope. Yes, good. So that right there is real-time capability between all of your devices, something in Azure and this laptop. If we look at some of the other experiences that are on here, this one is a little bit silly. You should see on your device a picture of a dog and a cat. And it looks like, I think we are kind of in between. No, we're equal. We've got enough dog lovers and enough cat lovers in here. Let's try another little one, which is a little bit less silly, and we can ask really important questions like, have you ever raised a Kubernetes cluster? Yeah, okay, so we're even there. Have you ever used jQuery? Yeah, okay, a lot more use it. Do you still use jQuery?
Have you ever used Serverless?
Serverless, we've got some serverless users out there, yeah, good. So we'll skip over to something that's hopefully a little bit even more interesting, which is this one here, and I'm not gonna tell you what to do, you can just hopefully work it out. If you are not connected, the people that are on their device have two buttons. One of those buttons, both of the buttons are the color of these little bats on the side here. And without me explaining it, everybody's determined exactly what they need to do. Now, this is a team game in that if you push up, you are only pushing up for the percentage that you represent on that team. So if there's enough of you that hate your team members and push the other way, then the bat will not move. Interestingly, with any group of people, Red's struggling a little bit there. Red's got some haters. An interesting thing about this experience is that audiences seem to intuitively just determine how to use it. I can do some weird things like make it possibly a little bit harder for you by can we do that? Let's. Oh, look at this! Look at Red go! Look at it was so close. Maybe we'll speed you up a little bit. We can make the ball slow down and that kind of thing. But just note that this is entirely based on SignalR in that. Oh, look at that! Is that a bug? That's the first time I've seen a bug as well. Do you know? Oh, it's because ball speed's negative. There we go. Yeah. I need to block that. Now get that one. That's a fast one. Oh, Red got it. The interesting thing about this is that every time you push the button down and every time you release the button, that is a message going across that persistent connection to a VM in Azure that then broadcasts that result to this laptop. And everybody is doing exactly that. So there's a lot of messages on that one. The last thing that we'll look at is something that maybe we might use in a team scenario. If you're having a meeting, if you're doing a retro, if you're doing sprint planning or something like that. Bears, if you want bears. If you're not connected, people's devices right now just have a text box in there, and they can put whatever they want up on that screen. Bears is generally the call. We can move these around as if they are little post-its. We can move the screen around as well, and very much different to normal post-its. We can do this little thing and see who put. We've got Donald Trump and Bill Gates in the house. Nice. Thanks for joining us, guys. So again, that's every time you're sending those messages, they're being sent across those persistent connections and being sent to this laptop, which is Pretty cool. And I think that might be all of them.
Just switch to the references. So we provided all the references in our weblogs. So basically, the first one is the Stafford, the second one is mine. Everything about Azure SignalR, Azure Functions, how to do it serverless, and how to use the crank here, and load testing, everything.
Automating VMs
Yeah,
at scale.
automating VMs, yeah. They are all here, and please have a look. And thank you so much for listening. If you have any question, please. Thank you.
Cool.
Cheers, guys.
Thanks, everybody. Now I'm going to go get one of those beers.
So,